In this module, we zoom in on a powerful frontier, using AI to find, evaluate, and monitor real-world assets before they ever hit a blockchain. You'll see how better data, smarter models, and automation can reshape origination, underwriting, and ongoing risk oversight across the entire RWA lifecycle. To see why AI matters for RWAs, think about all the data exhaust real assets produce. Contracts, PDFs, bank feeds, invoices, sensor readings, even news sentiment. On its own, this information is messy and incompatible with blockchains. AI and machine learning act as a translation layer. They read, classify, and summarize that exhaust into clean, structured metadata that smart contracts can actually use. That's what turns a warehouse full of documents into programmable on-chain assets. Traditional RWA deals are built around snapshots, standardized data, a single credit score, quarterly reports, and humans checking covenants after the fact. AI turns that into a continuous dynamic system. Instead of relying only on official statements, we can tap alternative and unstructured data, the digital exhaust. Scenario-aware models translate that into narratives and risk signals streamed through real-time APIs with automated alerts when behavior deviates from what was expected. The first phase is origination. AI upgrades it from ad hoc deal hunting to a systematic pipeline. Models constantly scan the market, ranking potential originators by performance and strategic fit. Large language models then triage pitch decks, data rooms, and legal docs into clear, comparable summaries. On top of that, external signals, like news, hiring, or regulatory changes, update those views in near real time. Before capital flows into an RWA pool, you need a clear picture of who you're dealing with and what could go wrong. Diligence today is about connecting many messy data sources: company registries, beneficial owner databases, sanctions and litigation records, plus ESG and controversy feeds. Entity resolution links all those fragments into a single profile. From there, algorithms can cluster lookalike assets to build a portfolio within risk limits, while automated checks keep screening counterparties in near real time. Traditional finance usually reduces a borrower to a single score and a binary decision, approved or declined. That scales, but it hides why the decision was made and what could change it. An AI-native approach treats risk as a live story. Models break risk into drivers like macro conditions, collateral quality, and behavior, then generate short explanations. That lets RWA protocols monitor shifts over time, challenge inputs, and design covenants that react to specific risk factors, not just a threshold. Stress testing is where AI starts to feel like 1,000 analysts on demand. You take macro shocks, rate hikes, supply chain breaks, currency swings, and push them through your asset models to see how portfolios behave over time. Machine learning helps generate synthetic but plausible crisis paths, not just replay 2008 forever. The output isn't just statistics, it's narratives. Under scenario A, junior tranches are wiped. Under scenario B, covenants trip in year 2. Governance can then set limits before capital is deployed. Continuous monitoring is where an RWA deal stops being a static document and becomes a live data system. First, cash flows stream in through real-time ingestion. Every payment, prepayment, or recovery hits your dashboard as soon as it's recorded. Second, you track operational KPIs like approval rates and collection efficiency to see if the originator is behaving as modeled. Third, you overlay external signals, markets, macro data, even supply chain telemetry, to detect stress early and trigger governance or covenant responses. In a traditional structure, you often find out something is wrong only when a covenant is formally breached, usually in a quarterly report. By then, the damage is mostly done. AI lets you insert an earlier phase, anomaly detection. Models watch millions of tiny signals, payment timing, operational data, external news, and learn what normal looks like for that asset or pool. When behavior drifts from that baseline, you get a soft alert, not a default notice, giving governance time to investigate, engage the originator, and course correct. Think of AI, humans, and governance as a feedback loop. AI engines handle the velocity. They pull in data, spot patterns, and raise alerts far faster than any team could. Systems provide the guardrails, audit trails, model risk management, and regular recalibration, so you can actually trust the outputs. Humans stay at the steering wheel. They review edge cases, override when something feels off, and update the rules. Enterprise-grade RWA governance is that loop running continuously, not a one-time setup. When we use AI to underwrite real-world assets, biased data quietly becomes legal and economic risk. If past lending ignored certain regions or founders, the model will learn that those groups are always riskier. Even if we strip out sensitive fields, proxies like zip code, industry, or ticket size can recreate the same discrimination. So RWA builders need mandatory fairness testing, monitoring by cohort, and optimization that enforces equity constraints, not just accuracy before models ever touch real capital. Overfitting is what happens when a model learns the quirks of a bull market instead of the underlying economics. It looks amazingly accurate right up until the regime changes, then performance collapses. For RWA, that's dangerous because real economies move in messy, uneven cycles. Your goal is robustness, not perfection. Test models on out-of-sample periods, explicitly simulate regime shifts, and add conservative overlays. If a model only works in the good times, it doesn't work. When you bring AI and complex models into regulated RWA flows, the real bottleneck isn't raw accuracy, it's explainability. Supervisors don't just ask, was this decision correct? They ask, show me why, in a way I can audit. That means every declined borrower, every covenant breach, every parameter change needs a clear, consistent trail from input data to model output to human-readable rationale. LMs can help generate those narratives, but only if they're strictly constrained by verifiable data, not free-form storytelling. To wrap up, translate this into your own context. First, pick one spot in your RWA pipeline where AI could create clear, near-term value. Then be honest about the infrastructure and data gaps that would block it. Decide how humans stay in the loop. Finally, make your guiding principles explicit before you deploy anything.